When a massive star runs out of fuel, gravity wins the final battle. A stellar core containing more mass than our Sun collapses inward, crushing the material into a city-sized sphere roughly 20 kilometers across. Inside that tiny volume, an apocalyptic amount of thermal, rotational, and gravitational energy is suddenly trapped. Gravity pulls inward with such intensity that if the star cannot process and release this energy, the entire structure will fail and vanish into a black hole. To maintain equilibrium, the star functions as a multi-scale processor. It layers 5 distinct branches of physics, from the general relativity of its gravity to the subatomic quantum mechanics of its core, to vent energy through 3 parallel pathways. This is a high-stakes balancing act, a dynamic machine in a state of constant automated survival against its own weight. The first pathway handles the heat. Millions of degrees of residual thermal energy must travel from the deep core out into the vacuum of space. As this heat moves outward, it hits a boundary layer governed by nuclear physics. Here, pressure forces atomic structures to deform into bizarre geometries known as nuclear pasta, parallel cylinders and flat sheets for energy transport. This intense pressure triggers a quantum conversion, transforming the trapped heat into subatomic particles called neutrinos. Neutrinos carry no electrical charge and almost zero mass, allowing them to pass straight through the remaining solid matter of the star without slowing down or interacting. At the very surface, the crust also converts a portion of this escaping heat into high-frequency X-rays, radiating them directly into space. By continuously converting and venting heat through these particles and radiation, the star prevents its internal temperature from reaching the threshold of total collapse. While the interior manages heat, the exterior manages motion. The collapse concentrates the star's original momentum, resulting in a mechanical spin that can reach hundreds of revolutions per second. This rapid rotation whips the star's intrinsic magnetic field into a massive electromagnetic generator extending far out into space. The speed of this rotating magnetic field creates a potential difference of quadrillions of volts across the poles. That voltage accelerates charged particles to near light speed, blasting rotational energy outward as sweeping beams of radiation, turning the star into a cosmic lighthouse. By transforming mechanical spin into electromagnetic radiation, the generator actively bleeds off kinetic energy that would otherwise destabilize the star's rotation. The most violent energy transfer happens at the boundary where the solid outer crust meets the fluid inner core. The inner core exists as a quantum superfluid, a frictionless liquid that retains all of its original angular momentum and resists slowing down. This creates structural tension. The solid outer crust is gradually slowing its spin due to magnetic drag, but the internal superfluid continues to rotate at its original speed. Quantum vortices in the fluid become pinned to the crystalline lattice of the slower crust, building massive mechanical stress between the layers. The crust eventually fractures in a starquake, forcing the vortices to suddenly unpin and release their energy. This snaps the pent-up momentum from the core into the crust, causing the entire star to jerk forward and visibly speed up, an event known as a glitch. The glitch cascade functions as an active feedback loop, regulating the dangerous friction differential between the quantum core and the solid-state crust. Operating alone in the deep vacuum of space, the neutron star survives by perfectly balancing these 3 extreme pathways. This reveals a principle of systems theory known as Ashby's law of requisite variety. Ashby's law states that for a system to be stable, its internal complexity must match the complexity of the pressures it faces. A neutron star persists because its internal architecture, the layers of pasta, the quantum superfluids, and magnetic fields, provides the exact amount of variety required to process the forces trying to destroy it. It is a system that exists only because it is in a state of constant layered motion.